Good afternoon, dear students. Today I am going to cover the miscellaneous treatment part 2. Actually, in part 1, miscellaneous treatment in part 1, I have covered two things, that is lime soda process and zeolite process. Okay, so those lime soda and zeolite process were to remove the hardness of the water, okay, to convert the hard water into soft water. Now, in second part of miscellaneous treatment, I am going to discuss two things once again. One is desalination and second is fluoridation and defluoridation. So these two things we are going to cover in today's lecture. It is very simple and interesting. What is desalination? Desalination is a process that takes away mineral components from saline water. Salt water is desalinated to produce water suitable for human consumption or irrigation. So, desalination means the removing the salts present in the water. So, that water is called salty water or saline water. Or saline water is not good for our consumption. Therefore, see, best example for saline water is sea. See, it has got saline water. So, salt, they are called dissolved solids. Salt means dissolved solids. So, whatever the dissolved solids are present in water, that can be removed. That process is called desalination. So, now what are the desalination? Desalination by reverse osmosis process, that we can just discuss because this is specifically emphasized in your syllabus. So, before studying, now let us see what is that desalination by reverse osmosis process, which is most commonly used. Okay. Now let us see. Before studying reverse osmosis, we shall first understand what is osmosis. So what is osmosis? We must understand first, and then what is reverse osmosis? That we will understand. Okay. So here clearly written. See, in osmosis, when salt solution is separated from pure water by a semi-permeable membrane, the pure water flows across the membrane, until the pressure on the pure water side become equal to the osmotic pressure of the salt solution as shown in figure. So I think better way I will explain with the help of figure. First we will go to the figure, so then I will explain you with the help of that figure. So that figure is here. This one is that figure. So first one, I will explain what is osmosis. So osmosis was first we will understand. So in osmosis, in this figure, if you just notice, you will see two compartments, 1 and 2. Left side one compartment, right side compartment 2. Okay. So in this case, what you can see is at the center, these two compartments are separated by a semi-permeable membrane. Semi-permeable membrane. So, in compartment 1, you will see salt solution, and in compartment 2, that is clear water. So, if there is a semi-permeable membrane, and in compartment 1, salt solution is placed, in compartment 2, pure water is placed, here, osmosis process will take place. What is osmosis? The pure water from the second compartment will flow towards the salt solution through the membrane. So this semi-permeable membrane will allow water to pass through and go towards the salt solution. So this type of process is called as osmosis. Whereas reverse osmosis, what is reverse osmosis? So this one is osmosis. Let us see what is reverse osmosis. So reverse osmosis is here. So this one is a figure showing the reverse osmosis. Here again there are two compartments, left side one compartment, right side one compartment. These two compartments are separated by a membrane, semi-permeable membrane, you can see here. And here what is happening, in left side compartment salty water is there, that is concentrated solution. Left side salt water is there, and on right side pure water is there. So what is being done here, in this condition, this is called reverse osmosis, where the water from the concentrated solution, that is water from the salty solution or salty water, will move towards the clear water solution. See, arrows are showing here. arrows are being shown which are moving. So the arrows which are passing through the membrane, they are water, pure water is passing, and salt is not passing here. Salt is there only in first compartment, left compartment only, and only water is passing through the membrane. So whereas in osmosis, water is passing through the membrane and moving towards the salt solution. Here in reverse osmosis, from salty solution or from salty water, only water is passing through the membrane towards the clear water. So thereby we are getting the pure water or fresh water in the right compartment, and the concentrated solution will be at the left compartment. So this is reverse way of the osmosis. So therefore it is called reverse osmosis. Do you understand why it is reverse osmosis? Because in osmosis, water moves towards the salt solution. In reverse osmosis, water from the salt solution moves towards the water. Understand? So this one is reverse osmosis. So the second figure is showing reverse osmosis. So principal sketch showing the reverse osmosis. So you can understand this. So in case of osmosis, water is moving towards the salt solution. In case of the reverse osmosis, water from the salt solution will move towards the fresh water other compartment. So both are moving through the membranes only. These semi-permeable membranes are provided for that. Then you may ask one question: why it is reverse osmosis? How it can occur? In this case, in reverse osmosis, what is being done is a pressure is applied to the concentrated water. Pressure is applied to the salty water, left side. If you see in the left side, pressure is applied to the salty water so that the membrane will pass. The membrane is designed in such a way that that membrane will allow to pass the only water through the membrane, not the salt. So dissolved solids are not allowed, only water is allowed to pass through this membrane. Such a membrane is specifically prepared and that is used in case of the reverse osmosis. So I think you have clearly understood what is reverse osmosis. So let us go with very fast. That same thing theory is written over here. Dear students, I am going to send this theoretical part also to you. These notes I am going to forward you, so you can once again go through. So only explanation I am giving you very briefly, and now you understand. So you understand, desalination means removing the salt from the water or separating the pure water from the salty water. So that type of process is called as reverse osmosis. So this reverse osmosis is one method which is used for desalination process. So the same thing, whatever I explained, the same thing written over here. So in the second para you see, in reverse osmosis, the water molecules and the salt ions are separated by the forcing the salt solution against the semi-permeable membrane barrier, which permits the flow of water through itself but stops the salt as shown in figure. So salt is not allowed to go, only water is allowed to go through the membrane. The meaning of this paragraph. Next paragraph we will see. So what is next paragraph? So in reverse osmosis process, the natural osmotic pressure is opposed by exerting an external pressure on the side containing the salt solution. In other words, the osmotic pressure is reversed. So whatever I have explained, the same thing is written over here. So I think this one is very clear to you. You have understood it very well. So reverse osmosis process is used by applying pressure. Now let us see what are different pressures applied. So in semi-permeable membrane. So semi-permeable membrane used in this process is hence thin but dense and strong enough to withstand the high external pressure. Okay, reverse osmosis does not work below 60,000 kilonewton per square meter, that is 600 kg per centimeter square, and usually operated at about 1 lakh kilonewton per square meter. Okay, pressure. So what is the pressure given? The semi-permeable membrane used in this process should withstand such a pressure. Okay, it should withstand the high external pressure. In high pressure only water passes through the membrane. Okay, so it is not as usual. Osmosis is natural. Osmosis process is natural, whereas reverse osmosis we have to apply the force. By applying the force only the reverse osmosis takes place. Okay, so what is the force applied? It is the pressure is like this, 60,000 kilonewton per square meter pressure is to be applied, and that pressure must be sustained by the membrane which is used for the reverse osmosis. So this membrane is very important. Reverse osmosis, whatever membrane we are using is very important. Okay. So pressure driven force. So automatically what happens? There are in all pressure driven. Now in reverse osmosis, what you have seen is it is pressure driven force. Okay. Then as the reverse osmosis is highlighted and emphasized in your syllabus, I have explained in detail. But pressure driven process means there are almost 4 types of pressure driven forces. So what are they? They are here. See, these processes are microfiltration, that is MF. Second one is ultrafiltration, that is UF. Third one is nano filtration, that is NF. And fourth one is reverse osmosis, that is RO. Now these are all pressure driven processes for separating the water from contaminants. Okay. So let us see, microfiltration means what? Actually, reverse osmosis is very small particles can move. What are the small particles which we can move in reverse osmosis? That I will see in later state. Now here, what are microfiltration? These can be observed. There is a figure, so these can be observed from the figure 9.53. So nano filtration as well as the reverse osmosis help in filtration of dissolved salts. So I will show you that figure. That figure is here. See this figure. So the different pressure driven forces. Okay. Now you can see. Here. So here sand filtration. At extreme right bottom you see sand filtration. So sand filtration works from 10 micrometer to 100 micrometer force. Okay. And microfiltration work from 0.1 micrometer to 10 micrometer, and ultrafiltration work from 0.001 micrometer to 0.1 micrometer, and nano filtration left side you see that work from even less than 0.001. Okay, 0.001 and even less than 0.01. So that range is given here. And reverse osmosis is very perfect and very pure. Here 0.0001 micrometer to 0.001 micrometer. So up to that extent it can work. So reverse osmosis means the membrane should sustain such a great pressure that even such a small particles, so it is 0.0001 micrometer to 0.001 micrometer. Micrometer means you can understand that is so such a small quantity of particles can only move. So in such case, in reverse osmosis, only in such case, only in this range, only water can move through the membrane. So that membrane is designed in such a way that only 0.001 micrometer to 0.001 micrometer range particles can move through the membrane. So such membrane is very difficult to design, and nowadays reverse osmosis is commonly used. So this one will give you the better idea, correct idea how the reverse osmosis is so much what you call powerful. So here out of these 4 filters, that is microfiltration, ultrafiltration, nanofiltration, reverse osmosis. So this reverse osmosis will allow very smallest of the smallest particles that I have already told you what type of particle. So in nanofiltration what happens, let us see. So here nanofiltration, you just go through here. Nanofiltration follows the same principle but utilizes a macro pore membrane. RO rejects particles of size as small as 0.001. RO rejects particles of size as small as 0.0001 micrometer, whereas NF rejects particles of size 0.001 nanometer. So that means here you can see NF and RO are very minute particles. So these two are commonly being used in separation of water from the minerals. Okay, if a salty water is there, saline water is there, any other contaminants are there, that can be easily separated by either reverse osmosis or nanofiltration. So you are expected to remember these differences. Okay, what is RO rejects? RO rejects particles size as small as 0.0001 micrometer, and NF, that is nanofiltration, rejects particles of size 0.001 0.001 nanometer. So this one is what you can see, understand. So reverse osmosis can be used for desalination with low pressure membranes, okay, of moderately salt water. So what should be the TDS of the salt water? Even salt water is having TDS, that is total dissolved solids. What is TDS? TDS stands for total dissolved solids, okay, this TDS. So 1000 to 10,000 milligram per liter. So okay, 1000 to 10,000 milligram per liter salt is there in water. In such case also reverse osmosis is useful, okay. High pressure membranes so for reverse osmosis, all these are actually pressure driven force, okay. These filters are working with a pressure, microfiltration, ultrafiltration, nano filtration and reverse osmosis. So in your syllabus you have to concentrate more on reverse osmosis and nano filtration. So you must know more about nano filtration and reverse osmosis. That is enough for your syllabus point of view. So remaining things are also there, you have to remember, okay. So all this theory I have given you, I will definitely forward you this one for your reading purpose. I have systematically prepared, so you go through. So now let us see second part. Second part what I have told, first part was desalination. Now we have discussed all these things in case of desalination. Now we see what we have to do, that is fluoridation or defluoridation. So second part is addition and removal of fluoride. So what is fluoridation? Before knowing what is fluoridation, what is fluoride? So fluoride is a chemical which is contained in water, but this chemical should not be more than 1.5 milligram per liter or less than 0.8 milligram per liter. So here fluoride in drinking water should be in the range of 0.8 to 1.5 milligram per liter. So this is beneficial for our health. So if fluoride is not there, if it is less than 0.8, it is not beneficial. If it is more than 1.5 milligram, it is also not beneficial. So it must be within this range. So if the water is not, what is fluoridation then? Fluoridation means if the water is not having fluoride, or if the water is having less than 0.8 milligram per liter fluoride, then we have to add the fluoride. So that fluoride adding process is called as fluoridation. So to ensure this fluoride, fluorides are added to the water if found deficient. So this process of addition of fluoride to the water is known as fluoridation. So fluoridation means adding the fluoride to the water if it is less than 0.8 milligram per liter. Understood? So that fluoride is added and that process is called fluoridation. So in this para I have written everything very clearly. So why fluoride is essential? I read out very fast, please remember. So it has been believed that if the fluoride concentration in water supply is less than the optimum value, the water proves harmful as it may result in dental caries in children. It has thus been believed that during the formation of permanent teeth in children, scarcity of fluoride in consumed water may lead to formation of weak tooth. So that means ಮಕ್ಕಳ ಹಲ್ಲುಗಳು ವೀಕ್ ಆಗ್ತಾವೆ. ಫ್ಲೋರೈಡ್ ಕಂಟೆಂಟ್ 0.8 ಮಿಲಿಗ್ರಾಮ್ ಪರ್ ಲೀಟರ್ ಅಂತ ಕಡಿಮೆ ಇತ್ತಂದರೆ ಹಲ್ಲುಗಳು ವೀಕ್ ಆಗ್ತಾವೆ ಮಕ್ಕಳಿಗೆ. ದಟ್ ಇಸ್ ವಾಟ್ ಇಟ್ಸ್ ರಿಟನ್ ಹಿಯರ್. ಸೊ ಇನ್ ದಿಸ್ ಪ್ಯಾರಾ ಯು ಕ್ಯಾನ್ ವೆರಿ ಸಿಂಪಲ್ ಆ್ಯಂಡ್ ಲೂಸಿಡ್ ಇಂಗ್ಲಿಷ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಬರ್ತೀವಿ, ಓದ್ಕೊಂಬಿಡ್ರಿ. ಫ್ಲೋರೈಡ್ ಆಲ್ಸೋ ಪ್ರೂವ್ಸ್ ಬೆನಿಫಿಷಿಯಲ್ ಇನ್ ಓಲ್ಡರ್ ಪೀಪಲ್. ಫ್ಲೋರೈಡ್ 1.5ಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇದ್ರೂ ಡೇಂಜರು, 0.8 ಮಿಲಿಗ್ರಾಮ್ ಪರ್ ಲೀಟರ್ ಇದ್ದರೂ ಕೆಟ್ಟವು. ಸೊ ಡ್ಯೂ ಟು ಸಚ್ ಏಜ್, ದೊಡ್ಡವರಿಗೂ ಬೇಕು, ಇವನ್ ಇಟ್ ವಿಲ್ ಅಫೆಕ್ಟ್ ಆನ್ ದ ಬೋನ್ಸ್. ಫ್ಲೋರೈಡ್ ಆಲ್ಸೋ proves beneficial to older people in reducing the hardening of the arteries, and the fluoride stimulates the bone formation. So fluoride ರೇಂಜ್ ಒಳಗೆ ಇತ್ತಂದ್ರೆ ಬೋನ್ ಫಾರ್ಮೇಷನ್ಗೂ ಅನುಕೂಲ ಆಗುತ್ತೆ. ದಟ್ ಇಸ್ ವಾಟ್ ಇಟ್ ಈಸ್ ರಿಟನ್ ಹಿಯರ್. ಸೊ ಡ್ಯೂ ಟು ಸಚ್ ಏಜ್ ಓಲ್ಡ್ beliefs about the advantage of fluoride, its presence in public water supplies has been ensured by the addition of extra outside dose of fluoride. So fluoride add ಮಾಡ್ತಾರೆ. So as far as possible fluoride must be kept 1 milligram per liter. So ಅಲ್ಲಿ ಆ್ಯಡ್ ಮಾಡ್ತಾರೆ. ಸೊ ಆ್ಯಡಿಂಗ್ ದ ಫ್ಲೋರೈಡ್ ಟು ವಾಟರ್ ಇಸ್ ಕಾಲ್ಡ್ ಫ್ಲೂರಿಡೇಷನ್. ಇದರ ಮೆಥಡ್ಸ್ ಆಫ್ ಫ್ಲೂರಿಡೇಷನ್ ಕೆಲವು ನೋಡ್ಕೊಂಬೋದು. What are the methods of fluoridation? So fluoridation is achieved by addition of outside fluoride compounds. What are those compounds? The following are the some compounds which are added to the water. So sodium fluoride, first one is sodium fluoride, second one is sodium silicofluoride, third one is hydrofluorosilicic acid. So out of these compounds, sodium fluoride, first one, sodium fluoride, that is NaF, is most commonly used and generally fed under pressure as a solution. Okay, with a pressure, it is applied to the water with a pressure. Okay, so that is first one is important. You must remember that name. Out of course, all these three names you have to remember. So fluoride, methods of addition of fluoride or fluoridation. So three methods, that is three compounds are used, either sodium fluoride or sodium silicofluoride or hydrofluorosilicic acid. So these three compounds, out of these three compounds, sodium fluoride, first compound, is most commonly used. So okay, now how it is used, actually there is a figure, the process feeding arrangement for fluoridation, it is given. You just refer this figure. You are not expected to remember this figure, or you are not expected to reproduce in the examination. If fluoridation notes you have to write down, no need of drawing figure. But if you draw this figure, it is supportive, it is well and good. So feeding arrangement for fluoridation. So how the water is feeding is done. So I am not going to delve in detail. You just refer this figure. Here everything is given. You have to draw the figure, and from here the injection nozzle is provided for a fluorine compound, and so how it is fed by the pipe, how it is added, everything is here. It is not essential to explain this very clearly also, but this is a setup used for the feeding arrangement of the fluoridation, that you must remember. Okay, you refer this figure also. So let us see the second part, defluoridation. What is defluoridation? Defluoridation means removing the excess fluoride present in water. So I already told you, fluoride must be within the range of 0.8 milligram to 1.5 milligram per liter. So if it is more than 1.5 milligram per liter, then it is also harmful to our human body. So therefore, we have to remove if the fluoride is more than 1.5 milligram per liter in the water. So that is called excess fluoride. So if fluoride is excess, second para, if fluoride is excess in the drinking water, then 96 to 99% of it combines with bones. Since fluoride has affinity for calcium phosphate in the bones, excess intake of fluoride can lead to dental fluorosis. Dental fluorosis excess ಆದ್ರೂ ಇದು ತ್ರಾಸ ಕೊಡ್ತದೆ. So if fluoride is excess, then also it is harmful. So what will kill? Dental fluorosis, skeletal fluorosis, and non-skeletal fluorosis. See, these are the diseases if the fluoride is more excess in the water. Okay, what is that? First one, dental fluorosis and skeletal fluorosis and non-skeletal fluorosis. So all these are occurring. So therefore, non-skeletal fluorosis means actually it is gastrointestinal problem. Okay, but anyway, they are harmful to our health. So that much you remember. So if the fluorosis can be avoided, then extra fluoride must be removed. So let us see what are the methods of defluoridation. So what is defluoridation? Defluoridation means removing the excess fluoride from the water. So these are the methods. First one is absorption by activated alumina. Okay, it is also known as Prashanti technology. Second one is ion exchange absorption method. And third one is Nalgonda technique. And fourth one is reverse osmosis. Again, reverse osmosis comes into picture here. So in desalination also reverse osmosis is used, process is used, and in defluoridation also. So desalination also reverse osmosis is used, and defluoridation also reverse osmosis. So out of these four, this third and fourth are important as per your syllabus point of view. So it specifically asked us to emphasize on third and fourth method, that is Nalgonda technique and reverse osmosis process. So, but anyway, all the four things we will discuss in brief, okay, very briefly. So first one, absorption by activated alumina. In this method, the raw water containing high contents of fluoride is passed through the insoluble granular beds of substance like activated alumina, okay, or bone char, or activated carbon, or serpentinite, or activated bauxite. So these are all the different substances through which water is passed. So here what happens? Excess fluoride is absorbed by these medias. What are they? Activated alumina, bone char, activated carbon, activated bauxite. These will, if the water is passed through this, then it will absorb all those things. Fluoride, extra fluoride is expert. So this is first method. Second is ion exchange absorption method. So this process of ion exchange is similar to that of used in removing the hardness from water. So hardness ನೋಡಿದ್ವಿ ನಾವು. ಹಾರ್ಡ್ನೆಸ್ ಒಂದು ಯೂಸ್ ಮಾಡಿದ್ವಿ. ಏನು ಗೊತ್ತು ಯೂಸ್ ಮಾಡಿದ್ವಿ ನಾವು? ಜಿಯೋಲೈಟ್ ಯೂಸ್ ಮಾಡಿದ್ವಿ. ಸೊ ಜಿಯೋಲೈಟ್ ಟೈಪ್ ಇದು ಕೆಲಸ ಮಾಡ್ತದೆ. ಸೊ ಹಿಯರ್ ದ ಪ್ರೋಸೆಸ್ ಆಫ್ ion exchange is similar to that used for removing the hardness from water. Here a strong base anion exchange, that is zeolite, in the chloride form is used. Water is passed through this bed of resin. So water is passed through the bed of resin means zeolite, okay, contained in a pressure vessel. So this process remove the excess fluoride. So it's very simple. So water is passed through the zeolite to remove the to remove the fluoride, excess fluoride. So third one is again Nalgonda technique. So Nalgonda technique is very important. In India and particularly in rural areas, groundwater containing excess fluoride is treated by Nalgonda technique. So in India it is most common. Why Nalgonda technique is highlighted in syllabus? Because in India it is specifically used for rural side. So treat the rural side. So generally fluoride is more in the groundwater. So well water, bore water, what we say, the fluoride content is more. So that fluoride content is removed. So this technique is found to be simpler and economical than the above mentioned fixed bed ion exchange method. So fixed bed ion exchange method ಕಿಂತ ಇದು ಥರ್ಡ್ ಮೆಥಡ್ ಭಾರಿ ಯೂಸ್ಫುಲ್ ಅದ. ಸೊ ಇದ್ರೊಳಗೆ ಏನದ ಅಂತ, ದಿಸ್ ಟೆಕ್ನಿಕ್ ಈಸ್ ಫೌಂಡ್ ಟು ಬಿ ಸಿಂಪ್ಲರ್ ಆ್ಯಂಡ್ ಎಕನಾಮಿಕಲ್ ದ್ಯಾನ್ ದಿ ಅಬೋ ಮೆನ್ಷನ್ಡ್ ಫಿಕ್ಸ್ಡ್ ಬೆಡ್ ion exchange process, since it does not involve regeneration of media and employs chemicals which are readily available. ಸೊ ಕೆಮಿಕಲ್ಸ್ ರೆಡಿಲಿ ಅವೈಲೇಬಲ್ ಇದ್ರೆ ಯೂಸ್ ಆಗ್ತದೆ. ಅದಕ್ಕೆ ನಲ್ಗೊಂಡ ಟೆಕ್ನಿಕ್ ಈಸಿ ಆ್ಯಂಡ್ ಪರ್ಟಿಕ್ಯುಲರ್ಲಿ ಮೋಸ್ಟ್ ಸೂಟಬಲ್ ಫಾರ್ ರೂರಲ್ ಸೈಡ್. ಓಕೆ, ಅದಕ್ಕೆ ಕೊಟ್ಟರೆ. ಓಕೆ, ಸೊ ನಲ್ಗೊಂಡ ಟೆಕ್ನಿಕ್. ಸೊ ನಲ್ಗೊಂಡ ಟೆಕ್ನಿಕ್ ಬಗ್ಗೆ ಒಂದು ಸ್ವಲ್ಪ ನಾವು ಮುಂದೆ ಸ್ವಲ್ಪ ಸ್ಟಡಿ ಮಾಡ್ಬೇಕಂದ್ರೆ, ದಿಸ್ ಯೂಸಸ್ ನಲ್ಗೊಂಡ ಟೆಕ್ನಿಕ್ ಯೂಸಸ್ ಅಲ್ಯೂಮಿನಿಯಂ ಸಾಲ್ಟ್ ಫಾರ್ ರಿಮೂವಿಂಗ್ ದ ಫ್ಲೋರೈಡ್. ಓಕೆ, ದ ರಾ ವಾಟರ್ ಈಸ್ ಫಸ್ಟ್ಲಿ ಮಿಕ್ಸ್ಡ್ ವಿತ್ ಅಡೆಕ್ವೇಟ್ ಅಮೌಂಟ್ ಆಫ್ lime or sodium carbonate and thoroughly mixed. Alum solution is then added and water is stirred slowly for about 10 minutes. So this process is given. Anyway, I am going to send this note to you. You please read it, very important part. Wherever I have written bold letters, those things are very important. Please remember. So again there is setup for the Nalgonda technology. This is the setup. The figure is shown how the Nalgonda technology is done. You just remember this figure or draw the figure, or not essential to draw the figure, but only explanation is important. So this figure if you add in your answer, it is well and good. So here the raw water comes, how it is mixing done, okay, how the sedimentation is done, everything is done. Simply draw the figure, that is enough. So here bleaching powder is also generally added to the water. Okay, so alum is also added. Bleaching powder is also generally added with lime prior to the addition of alum. So to achieve the simultaneous disinfection of treated water, and also keep the system free from undesirable biological growth. So this one is very important. Now let us see what are the advantages. All these things you can go through. I am making bit fast because it is just theoretical. Even if I would have sent you the notes, it would have been done, but simply as a brief idea I am just explaining you. So advantages of Nalgonda technology: useful at community and household level. Okay, first. Second one is cost effective. Third one is indigenous technology. So that is very good. Indigenous suitable technology. Indigenous means most suitable for rural areas with less cost. Okay. Fourth advantage is low capital cost. So these are the four advantages: useful for community and household level, cost effective, indigenous technology, and low cost. Okay, low capital cost. So these are the four advantages. There are some disadvantages of Nalgonda technology. Let us see. Disadvantage of Nalgonda technology: one is technical expertise required. Second is time consuming process. Third is disposal of flux is a problem. Fourth one is alum dose needs regular calculation. Because if alum dose is more, it is again harmful. So therefore it must be regularly calculated and added to the water. So these are the four disadvantages of the Nalgonda technology. So and let us go to the next part, that is reverse osmosis. So reverse osmosis, again what is reverse osmosis? It is used for the defluoridation. removing the fluoride content in the water, more fluoride content, excess fluoride content. So excess fluoride is removed not only by Nalgonda technology but also by the reverse osmosis process. So let us briefly explain. Reverse osmosis process. In this method, the raw water is passed through the semi-permeable membrane barrier, which permits the flow of clear water through itself and blocks the flow of salts including fluorides. So reverse osmosis I already explained in the beginning only. So there is nothing much to explain you. Again, same process is being done here also. In desalination, whatever the process is done for reverse osmosis, same process will done in defluoridation also. Okay, so reverse osmosis is used in two cases, in desalination as well as in defluoridation. So I need not to explain much. The same thing is here. Okay, so what are the advantages of reverse osmosis? Let us see. So advantages of reverse osmosis. First one, different kind of membranes available. For reverse osmosis, so many different kinds of membranes are available. And second one is no chemicals are added here, so it is more safe. Third one is high fluoride removal efficiency. Okay, high fluoride removal efficiency. So efficiency more. Disadvantages, what are the disadvantages? It is cost ineffective for villagers. So in rural side it will be more costly. It is. And second one is poor after sales service in villages. So in villages after sales service is required. So that is not possible. That is one disadvantage. So these are the disadvantages for the reverse osmosis. Only two disadvantages there. But Nalgonda technique is commonly used in the village side. So with this, I think I have completed the even unit. Module 4. Module 4 is completed. So in module 4, I have covered everything. And now next is you have to remember and read yourself. All these notes I am going to forward you by just okay. So here today I have covered desalination and fluoridation and defluoridation. So out of these many questions are asked in the examination. Please be prepared very well. And from the next class I am going to start the 5th module. Okay, I hope you understood this completely. Thank you very much for listening.